Imagine this for a second. You're on an open water passage, maybe 40, 45 nautical miles offshore.
Right.
And you're battling some serious motion, some real weather. You need to pull down a critical weather update, or maybe someone just needs to check in with family. What does reliable internet look like then? I mean, it stops being a luxury, right? It's suddenly fundamental for safety, for operations.
It absolutely is. For any vessel operator out there, whether you're running a commercial boat or you're a cruising yacht owner, that connection feeling isn't just an inconvenience.
No.
It can actively compromise your ability to, say, reroute around a storm, download updated charts. The stakes are just so much higher than a movie buffering.
Exactly. And that brings us to our mission for this deep dive. Our listener, the learner, came to us with a very specific question.
Right.
They want a clear-cut analysis. Starlink V2 versus V3, specifically for vessels far from shore. They want to cut to the marketing and really get to what separates these generations for offshore use.
And that separation is so critical. I mean, if you look at the source material, the operational tests, the core finding is pretty immediate.
Which is?
This isn't just a minor tweak or a slight speed bump. The shift to V3, it's a fundamental architectural shift in how broadband gets delivered offshore.
Okay, an architectural shift.
Yeah, and that change, it influences everything from the service footprint to, and this is the most critical part, signal stability when the boat is pitching and rolling.
Okay, let's unpack that. We're going to move beyond the simple speed test and dive right into the hard operational reality of satellite internet at sea.
Sounds good.
So let's start with the tech itself. How do we define the key differences between V2 and V3 in a marine context?
Well, the first thing to remember is that V2, the second-gen constellation, it was already a massive step up from what came before.
Of course.
It was great near shore, delivered amazing speeds close to the coast. But its offshore reliability, that often hit a wall determined by satellite density and, crucially, by the hardware itself.
And when we move to V3, is it just about putting more satellites in the sky? Is it that simple?
It's a bit more complex than that. V3 brings in a new satellite architecture with these enhanced intersatellite laser links.
Lasers. Okay.
Yeah, and that new architecture, it supports much higher bandwidth and can handle way more users at once. But for you, the maritime user, the key takeaway is just one word: resilience.
Resilience.
V3 extends usable coverage dramatically. It pushes into regions that were, marginal or just dead zones for V2 because the satellites can talk to each other better before needing a ground station.
That makes a huge difference if you're crossing an ocean where ground stations are hundreds, maybe thousands of miles away.
Exactly.
So if V2 got us connectivity near the coast, you're saying V3 is what's unlocking truly dependable deep ocean operation.
That's it, precisely. It's about dependable offshore operation. It's about resilience. The core advantage is just stronger links maintained far, far beyond coastal waters.
And that ability to hold onto the signal while the boat's moving.
Yeah.
That's got to be key.
It's everything. It means consistent performance, even with weather variability, even with distance.
I get the technical side, but what about the cost? Doesn't that make the hardware cost jump, harder to swallow for a smaller owner if V2 is cheaper and gets me some service?
That's a fair question, and it really brings us back to operational confidence.
Okay.
The sources, they really emphasize that for commercial operators or yacht owners who depend on this for more than just weekend entertainment, the confidence that the connection will hold up, that alone justifies the cost.
So if your business depends on it.
Right. If you rely on that connection for safety or for revenue, the cost of a 2-hour dropout in the middle of a passage just far outweighs that upfront hardware premium.
That reframes the cost argument completely. It's an investment in uptime.
Exactly. The shift from V2 to V3 is really about migrating satellite from being a sometimes work solution to being a primary reliable utility at sea.
Here's where it gets really interesting. Let's look at what this new capacity translates to in practice. When a vessel is actually underway. We have some really good real-world data from these trials.
We do.
Where does that performance gap between the two generations become most dramatic?
The gap is starkest once you're continuously moving or operating well offshore. Let's say past that 30 nautical mile mark. The case studies show V3 just maintains significantly higher throughput and has far fewer latency spikes.
Let's dive into that first key example then, the Sport Fisher trial. This was a 90-foot sport fisher making an offshore run, about 45 nautical miles from the coast?
Yep, 45 miles out, well beyond the comfortable coastal zone for most systems. And this trial directly contrasted an older V2 standard dish with the new V3 flat high-performance kit.
So what did the V2 dish manage to do out there?
Under those conditions, moving offshore, it managed decent speeds, but they were inconsistent, around 180 megabits per second with about a 50 millisecond latency.
Which on paper is fast enough for browsing, for most things. What was the Achilles heel?
The stability. The V2 system had multiple brief outages, sometimes 30 seconds, sometimes a minute, just gone, over a 2-hour window. And those short gaps are exactly what kills a remote desktop session or drops a critical call. It was working, sure, but not reliably.
Not for mission-critical stuff.
Yeah.
Okay, now compare that to the V3 flat high-performance kit.
Night and day. The V3 result was nearly flawless. It consistently delivered speeds around 300 megabits per second, a huge boost, and latency dropped to below 35 milliseconds.
But the real win?
The real operational win was the stability. The vessel was running 4K streaming and remote desktop operations at the same time without a single interruption for the entire 2 hours.
That is a staggering operational difference. For the learner listening, that's the difference between being kind of functional and actually being able to run a business from the boat.
Absolutely. Think about the human element. You're trying to do remote work, you need a stable connection. Imagine hopping on a critical Zoom meeting 45 miles out. With V2, you'd be constantly worried, is the screen going to freeze?
Right when you hit a wave.
Exactly. The V3 system just gives you the confidence to operate as if you were tied up at the dock.
We also had that great case study about a 60-foot vessel upgrade. That one really highlights the improvement in geographic reach.
Yeah, that case is a perfect illustration of the older generation's limits. This 60-footer, with its standard V2 install, the performance would just start to degrade, to fall apart beyond 18 nautical miles.
Which, frankly, limits you to coastal cruising. You're not going far with that.
Not at all. After they upgraded to the V3 Marine configuration, that same vessel had 0 connectivity dropouts on a 48 nautical mile offshore run.
0.
Average speeds were solid, hitting about 280 millips with latency around 31 milliseconds. And this was while cruising at speed with typical offshore motion. The crew feedback was just glowing. They said it felt like a fast land-based connection.
So what's the secret sauce in the tech here? How does V3 handle that vessel motion? The pitch and roll. So much better.
What's fascinating is that V3 is specifically designed to mitigate that. Think of satellite tracking like trying to hold a flashlight steady on a target while you're on a trampoline.
Okay, I'm with you.
The V2 system had a relatively narrow beam, a narrow field of view. Its tracking motors sometimes just couldn't keep up with rapid changes. The V3, especially with the flat marine dishes, is designed with a wider net. It sees more of the sky, and its electronic steering is just much, much faster.
So, to use that analogy, the V3 system is essentially compensating for the sea state in real time. It's stabilizing the signal even when the horizon is pitching all over the place.
That's a great way to put it. It's compensating for the motion, which lets the terminal maintain that strong link, even in marginal satellite zones. And that translates directly to 0 dropouts during high motion.
Which leads us perfectly to the next critical piece of the puzzle. Because getting that signal isn't just about the satellites.
No.
It's about the receiver, the hardware choice, the installation. That's where the rubber meets the road.
Absolutely. You cannot get the full benefits of V3 coverage without marine-rated hardware. The satellite version matters, of course, but the terminal choice is equally critical for offshore reliability.
And a lot of people try to save money there.
They do. They try to repurpose a standard land kit, and they immediately run into problems.
So what's the core difference between that standard kit you'd put on your roof and a proper marine kit?
The standard kit is meant for a fixed location. Its field of view, its mounting, it's all limited. It's not engineered for constant motion, for vibration, or for the, extreme salt and temperature of a marine environment.
Whereas the marine kits are built for that.
Right. The marine kits, especially the flat high-performance dish, they're engineered with much wider sky visibility, robust weather sealing, motion tolerance. They even have internal heaters for ice. They're built for life at sea.
And the performance numbers reflect that optimization.
They really do. The older V2 high-performance kit, it generally maxed out somewhere between 200 and 500 millips. The newer V3 flat high-performance kit, though, optimized for those laser links, is capable of pushing sustained speeds into the 600 millips range.
Wow.
And can even peak near 1 gigabit per second. That's true high-speed broadband, far from land.
But getting those speeds, it requires a really careful installation. This is not a quick DIY job if you're serious about offshore use.
No, the installation demands are critical. We're talking about a multi-point checklist, and if you skip a step, you're going to have performance issues. First, Antenna placement is key.
High and clear.
High, unobstructed mounting location. Even a davit arm or a radar array can cause shadowing and block the signal when the vessel rolls.
Shadowing is a huge issue at sea, especially on yachts with a lot of superstructure.
It is. Second, you need robust power integration. These systems use a lot of power. You have to use marine-grade cabling, proper fusing, and robust 12 or 24-volt integration with surge protection. You can't just run an extension cord.
No, it needs to be properly bonded and grounded, too.
Absolutely. And once it's physically installed, the network integration comes in. You mentioned failover systems earlier.
I did.
That's the critical final piece. The terminal has to be connected into the vessel's network with marine-grade switches and, ideally, a sophisticated failover router.
So it's not just a standalone system.
For professional offshore operations, V3 is usually part of a hybrid system.
Wait, you used an acronym there, VSAT. What are you referring to when you mentioned VSAT backups?
Good catch. VSAT stands for Very Small Aperture Terminal. It's the older traditional geostationary satellite system.
Right, the big dome.
The big domes.
Yeah.
It's often slower, higher latency, but it provides near global coverage, and it's extremely reliable. So in a hybrid system, V3 Starlink is your high-speed lane. And if it's unavailable, say, in orbital gap or heavy weather, the router automatically switches to 4G or 5G if you're near shore, or to that VSAT backup for guaranteed continuity.
Which gives you much higher overall uptime.
Significantly higher.
So the decision isn't just V2 or V3. It's about building an entire, robust ecosystem around the V3 capacity to guarantee that connection.
Precisely. The system is only as strong as its weakest link. Offshore, that's usually the installation or the power supply.
Okay, let's tie this all together for our learner. We've seen the performance jump, we get the hardware requirement. If you're a vessel owner, how do you make that final choice? What operational needs define who absolutely needs V3?
You can define it pretty clearly by operational zone. If your vessel operates primarily near shore, say within 15-20 nautical miles, and you just need casual browsing, a refurbished V2 system can still be adequate and cost-effective.
But the moment you start talking about real voyages, serious cruising, professional use,
V3 becomes a necessity. It's the clear, non-negotiable choice for any vessel traveling farther offshore. The data shows stable connectivity from 30 up to 100 nautical miles or more off land. If you need continuous, low-latency connectivity for work, for commercial apps, for critical navigation while you're in motion, you have to opt for V3 hardware.
Let's hit that cost justification one last time. Since the V3 marine hardware is the clear winner, how do you justify that higher upfront cost?
The return on investment, the ROI, it's tangible and it's quick. You're investing in productivity and safety. If you're a yacht owner who otherwise relies on legacy systems like VSAT, the high cost of V3 is quickly offset by avoiding those astronomical VSAT bandwidth fees.
That's a huge one.
It is. Plus, the reduction in dropouts means better crew and guest satisfaction. For commercial use, it means better productivity, better security. It's an investment that future-proofs the vessel for the next 5 to 7 years.
So what does this all mean? Summarized simply, V3 isn't just a faster Starlink. It is the version that's purpose-built for the reality of life at sea.
Exactly. The enhanced coverage, the stronger motion resilience, the higher sustained throughput. It all positions V3 as the solution engineered for offshore realities. The advantages are measurable in speed, sure, but they're felt in tangible improvements to safety, navigation, and just the quality of life on board.
To quickly reiterate the most crucial points then for you, our learner, V3 offers broader coverage, much higher capacity, and superior offshore resilience. And remember, the hardware selection, getting that flat high-performance kit, is non-negotiable for reliable marine use outside of very limited coastal areas.
And this raises, I think, a really important final question for any vessel owner thinking about this. Even if your current V2 system works, K-ish, near shore, how much value do you place on specifying the newer V3 hardware today to create a truly future-ready system?
To avoid the regret later.
Exactly. Avoiding the regret of needing a costly, complicated upgrade 2 years from now when your cruising plans naturally extend. That's a calculation of long-term value versus short-term cost, and it's one every operator really has to weigh for themselves.